Hello everyone, myself Pawan. Today we are discuss the topic of TCP/IP model. As we seen in the last my video, we are discuss about the OSI model. And as we know, when we want to transfer the file on the network, we need the some model for this. So we have the two model for either we use the OSI model and the TCP/IP model. So today we discuss about the TCP/IP model. When we want to transfer the file on the network, obviously file is transferred from source node to destination node with the help of the, in between we have the number of the router when we transfer the file on the wide area network. In this, for transfer the file, we need the model. So TCP/IP help to transfer the file from sender to destination node. So TCP/IP is the combination of the TCP and the IP, and TCP is come before the OSI model. And even though if we are compare the layer of the OSI and TCP model, in OSI we have the 7 model and the TCP/IP we have the 4 layer. OSI come after the TCP/IP, but now the OSI is not fully implemented as we discussed in previous video. So now when we are trying to be send the file on the internet, we use the TCP/IP model. In TCP/IP was first developed prior to OSI model as mentioned, and TCP/IP we have the 4 layer in the TCP model. But now generally we use the, in the modern technology, some of the people they are use the TCP in the 5 layer model, and the TCP/IP is become the dominant commercial because it is used for the extensively in the for the internet. And when we transfer the file on the internet, obviously we use the TCP/IP model. The reason is that OSI is not the fully implemented. Now if we compare the OSI and TCP/IP model, in OSI we have the 7 layer as mentioned in the previous video, and then TCP/IP we have the 4 layer. In the, it is combination of the all 7 layer of the OSI model. In the, suppose we have the first 2 layer in the OSI model, we have the physical and data layer. So they combine the 1 layer in the TCP/IP model, and in OSI we have the network layer. In TCP/IP we have the internet layer, and then we have the transport layer same in both of them in TCP and the OSI model. And in the topmost layer in the OSI we have the 3 layer: session layer, presentation and application. In case of the TCP/IP they are combined all 3 layer in the one application layer. In the, if we are compare the OSI and TCP model, in OSI model we have not the ARP, RARP, ICMP and IGMP. If we move on the 3rd layer, network layer, ARP and RARP, ICMP, IGMP, they are the part of the TCP/IP model. And in the transport layer we have the TCP UDP service. In the last one we have the same, in the OSI model we have the HTTP service, we have the FTP, then we have the DSCP, then we have the telnet, DNS, SNMP and the SMTP. Now we move on the one by one on the every layer. Now first on the network access layer, the first layer, it is a combination of the 2 layer. First physical layer and the data link layer. As we seen in the OSI video, the purpose of this layer to transfer the, they are maintain all the physical network. They simply, when we want to transfer the file on the network, they first check the all the transmission mode. Then the all the topology come under this layer. Then we have the representation in the form of 0 and 1 bit. So what happens in this layer, suppose we, this is the layer, in this layer what, it is the first, is the lowest layer of the TCP/IP model. It is the first layer of the TCP/IP model, and it is a combination of the physical layer and the data link layer as defined in the OSI model. And the third one, it is the used to transfer the data sent physically through the network. What is the meaning of this? They are transfer the file on the, how to file transfer on the network, they mention on this. Then we have the number 4 is the, this layer is mainly responsible for the transmission of the data between 2 devices on the same network. So they are come on the transmission media. We have the simplex, we have the duplex, and we have the full duplex form in this. Then the 5th one is the function of this layer to encapsulate the IP datagram into the frame. As we seen in the OSI model, we in the data link layer we have the framing. In the first layer we transfer the file in the form of 0 and 1, change in the form of 0 and 1, then data reach on the data layer in the OSI model, then we are combining the number of frame. So same there is the constitute of the data into the form of the frame. Then we have the last is the mapping of the IP address into the physical address. As we mentioned in the, obviously when data reach on the upper layer from this layer on the network layer, we have the IP we are mention the address of the IP address. But in case of the physical and the data, we are use the address of the physical address. So what happen in this? The simply mapping of the IP address into the physical address. This is the role of this layer. So it is a combination of the both layer of the OSI and the physical layer and the data link layer. Then the upper layer is the then we have the network layer. The second layer of the TCP model is the internet layer, and we also known as the network layer. And the main responsibility of this layer is to send the packet from any network, and they arrive at the destination. Means they ensure to transfer the file from the source address to destination. So in this, as we remember in the previous video in the OSI model, what we have seen, we have the routing process. With the help of the routing, we are transfer the file from one address to another address. So what happens in this, they are ensure the file reach on the destination with the help of the routing process. The routing may be either we have the dynamic routing, or it may be the route is mentioned in the manually via the system admin. These are different topic. Then we have the IP addressing. The fourth topic is the IP addressing, fourth function of this. This is, as we mentioned, we have the data and physical layer. We simply mention the physical address, then data reach on the network layer. So this protocol implement logical host address known as the IP address, and the IP address are used by the internet and the higher layer to identify device and to provide the internet network routing. This is the main function of this. Then we have the host to host communication. The another function of this layer is to provide the host to host communication. Means it determines the path through which the data to be transmitted. Then the most important function of this layer is the fragmentation and the reassembly. When the data reach on the upper layer, from this layer, obviously data move on the network. With the help of the router or routing, we transfer the data on the over the network. Then we simply try to divide the data into number of parts. We have the packet, we transfer data in the form of the packet. So what happens in this, we divide the data into the packet, and we are simply fragmentation of this. So we are divide the data into the fragmentation, number of parts. We are called the fragmentation. So fragmentation may be done either on the sender side or in between the router also, intermediate router path. So what happens in this, we are divide the data into number of parts. Then they reach on the destination, we are reassembly all the fragment data in the original message. They are transferred to the original message. What is the benefit of this? Let's suppose we are using the dynamic approach of the routing, and we want to transfer the file on the internet. So simply packet move on the network. We have the number of paths to reach on the destination, and suppose we use the dynamic routing. So every packet move on the different path. With the help of the sequence number, they reach on the destination, and as the destination, we are simply with the help of the reassembly, we are join the all with the help of the sequence number. So what is the benefit of this? We have the option to transfer the packet on the different path with the help of this fragmentation, and with the help of the reassembling, we are again reassemble all of them at the receiver end. And the last function is the routing for this. So they are provide the path for the user to transfer the routing, as we mentioned in the previous slide. We have the two types of routing. We have one is the static routing, then the other is the dynamic. In first one, we have the enter the path manually via the system admin, and they have to follow the same path to transfer the file from source address to destination. In the dynamic routing, what happens? We are not provide the path given by the router, not given by the manually, and they depend upon the topology. They are transferred simply. Path is changed every time. Now there are some four parts of this network layer. One is first is the ARP, then we have the RARP, and then ICMP. So ARP is the address resolution protocol. The main function of the ARP is simply the mapping of the IP address into their physical address. When we want to transfer the file on the network, obviously we need the address of the destination. The address of the destination may be their IP address, or it may be their NIC address. Let's suppose we know the IP address of the destination. We want to send the file. So what, with the help of the ARP, we are map the IP address into the NIC address of the destination. What happens in this? ARP is the network layer which is used to find the physical address from the IP address. So what happens? The sender simply broadcasts the message of the IP address on the internet, and this simply with the help of the ARP request. When a sender wants the physical address of the device, it simply broadcasts the ARP request to the network. In the request, they simply mention the IP address of the destination. Then the second part is the ARP reply. Every device attached to the network will accept the ARP request and process the request, but only the recipient of the IP address, means which receiver have the IP address, they give the reply back to the in the form of the ARP reply packet. So this is simply mentioned, they put the physical address of their to the ARP reply packet. So since the recipient add the physical address of both of the to memory and to datagram header. So what happens in this? Simply I know the IP address, I want the NIC address of the destination. So we simply broadcast the message in the form of the ARP request packet. We simply mention the IP address and reach on the network. The receiver, those have the IP address, they simply give the reply in the form of the ARP reply packet. In the second we have the RARP. It is known as the reverse address resolution protocol. It just reverse the ARP. In the ARP we know the IP address of the destination. In the RARP we know the physical address of the destination. So simply what happen? We simply broadcast the physical address on the network with the help of this RARP. So RARP is the network layer in which we used to find the IP address from the physical address. So in the ARP request packet format, what they send? They simply send they want to know the IP address of the device. So they broadcast the RARP request to the network. In ARP request, what they mention? They mention the physical address of the destination. So they simply broadcast the physical address on the destination, physical address of the destination on the ARP request packet, and they broadcast on the internet, and the receiver, those have the same IP address, they reply back in the form of the RARP reply packet. Then we have the ICMP. The third part of this layer is the function of this network layer is the ICMP. ICMP stands for the Internet Control Message Protocol. It is the mechanism used by the host or the router to send or notification regarding datagram problem back to the sender. What is the meaning of this? Suppose we have some problem on the network in between the transmission of the file from source address to destination. So they simply send the message to the sender about the if any problem happen in between the transfer the file from source to destination. So we have the number of that problem, when maybe sometime we have the destination is unreachable from the source node. Sometime when the destination reply back to the sender node, source node is unreachable. Sometime we have the problem of the redirection. Sometime we have the problem of the routing also. Sometime we have the problem of the time to live. Suppose we transfer the file on the network, we are mentioning the TTL time, and maybe due to the routing problem the time is exceed. So we have the problem, so we simply send the message to the sender to exceed the TTL time. So what happens with the help of this ICMP, what we do? We simply send the message to the sender to send the back to the sender about the information about the what happened in the between the transfer the file in between the source to destination. So last point is the a datagram travel from source router to router until it reaches the destination. Means obviously what happened, they are transfer the file, datagram transfer from one place to different place. With the help of the in between we have the number of router and reach on the destination. Disable link, a device is on the fire or network congestion, then the ICMP protocol used to inform the sender the datagram is undelivered. This is the message given by the ICMP. Then we have the transport layer, then we have the fourth layer function is the transport layer. The fourth layer of the TCP is the transport layer. Transport layer is responsible to transfer the file from source to destination, and the transport layer use the two types of service. Generally we have the TCP and the UDP. So the main function of the transport layer is to responsible for they manage the transfer of the data from source to destination. Even they manage the flow control and the correction of the data which is being sent over the network. And the two protocols used in the transport layer, we use that UDP service and the TCP. Now we see the difference between the TCP and UDP service also. we have the two options to, with the help of transport layer, we either transfer the file with the help of the TCP, neither with the help of the UDP. The TCP is the connection oriented service. If we are compare both of them, TCP and UDP, if we use the service of TCP with the help of IP, either we use the UDP service. In TCP, we have the connection oriented service and UDP is the connection less service. And the TCP is the slow and UDP is the fast. What is the meaning of this? Because when we have the connection oriented service, obviously TCP made the three-way connection from sender to receiver to transfer the file first. In UDP, there is no three-way service of the connection oriented service. So simply UDP is fast. There is no connection between this. Then the TCP is the high reliability and this is less in compare of the TCP. Then we have the reliability, yes, ज़्यादा होती है इस पर. इसमें we have the minimum reliability 0. Then we have the error checking. In TCP, we have the error checking in the recovery. In the UDP, we have the simply error checking, no error recovery. And in UDP, TCP, we have the acknowledgement come back from the sender, receiver, when data reach on the destination. And UDP, there is no acknowledgement come back to the sender. So if we are compare both of them, TCP and UDP, TCP is the connection oriented service. Even TCP is slow, but TCP ensure to the sender data reach on the destination. In TCP, we have the acknowledgement also. In UDP, there is no acknowledgement come back to the sender. Then we have the last layer is the application layer. The last topmost layer of the, it is the topmost layer on the TCP IP model. And as we are compare the application layer of the OSI model and TCP IP, both are perform the same function. In the application layer, simply they are responsible for handle the high level protocol issue of the representation. They simply use the SMTP service, then we have the SNMP service, then we have the FTP, Telnet, DNS, HTTP. They all are come under the application layer. This layer, when we want to transfer the file or when we join to the another user. So with the help of this layer, we are joined with the user of the different device. So this layer allows the user to interact with the application. When one application in the layer protocol want to be communicated with the another application layer, it forward the data to the transport layer. Simply data, when data move on the reach on the receiver side, data come from the application, then transport layer, then the IP layer, then move on the first layer of the TCP IP model. So in application layer, we have the service of the SMTP. SMTP simply simple mail transfer. Then we have the SNMP, simple network management protocol. Then we have the FTP, file transfer. Then we have the Telnet. Then we have the DNS, domain name system. Then we have the HTTP. They all are the part of this application layer. I hope you understand this topic. As we seen in previous video, in OSI and the TCP, we both have the different layer. In OSI, we have the 7 layer. In TCP IP, we have the 4 layer. And as we seen in OSI model come after the TCP IP model, but it is not the fully implemented on the internet, or we can say if we compare both of them, the TCP ensure the user to reach the file on the destination. In OSI, there is no types of facility given to the sender to check the data reach on the destination or not. So TCP IP model is the best model if we are compare both of them to transfer the file on the internet. Thank you very much.